Okay, are there any questions about that? Anything that we need to talk about? Just kind of briefly, first question, I wish I had the thing where I could actually pull it up, but I don't. First question, you had a graph of a function. And I asked you a couple of things about it. To find f of -3. And then B, to find when f of x is equal to -3. Both of these are really just questions about finding points on the graph, right? In part A, what am I giving you? An x value or a y value? An x. So I'm asking for the y that goes with it then, right? Okay, so again, you've got the thing to look at. I don't have it here, but f of -3, that means when x is -3, what's the y value that goes with it? Well, there's a point on that graph at -3, 1. So f of -3 is 1, right? You don't have to try to figure out what that function is. You can do that, and a few people did it correctly. Most people who tried, missed some part of it somewhere, but you can do that. You can make that work. You don't have to though, because it's right there on the graph, right? It's just reading off, given this x value, what's the y that goes with it? Okay, so in part B, what's different? This is a y, and I'm looking for the x. So how do I handle that, doing that from the graph? Before we found x we found -3 on the x-axis and then looked up where the graph was, right? So if I'm giving you a y value now, we need to find -3 on the y-axis and then look up where the function is. So y equals -3 is right there. What I'm looking for is what x value or values go with that. And you've got it sitting in front of you, but when x is -1 or -5. So there are two values where that happens. That's that. My highlighting scheme is kind of getting out of hand here a little bit, but maybe that helps somebody. So again, it's just the difference between, are we given the inputs, right, the x value of the function and want to find the y, or are we given the output, the y value, and we find the x that goes with it. And then the domain and range thing was mostly fine. Some people had the range swapped, but for the most part, everybody was good there. The other question was, what is the function? X squared minus 3x plus 5, something like that. Is that right? And I asked you to determine analytically if that's even or odd or neither. Again, those refer to types of symmetry, right? Being even means it's y-axis symmetric. Being odd means it's origin symmetric. So like quadrants 1 and 3 look kind of upside down backwards. Neither means that neither of those things happen. But I also asked you to do it a particular way, right? And again, language I'm going to use on that kind of stuff is going to look a lot like language that you would see on tests because it's the same person writing it. So what I mean there is find g of -x. What g of -x is reflecting across the y-axis, right? We know that from the stuff we looked at last week. So what we're doing is a y-axis reflection. Simplifying, -x squared would be x squared minus 3 times -x, so plus. And then we want to compare these two things. And what are we looking for? Say again. If they have the same, if they're identical, if they're perfectly identical, exactly the same, what does that mean? It means when you do a y-axis reflection, nothing changes. That would mean it's even. Okay, they're not exactly the same, right? Okay, so it's not even. What else are we looking for? Okay, same values, but different. If they're completely opposite in sign, right? As if you took this thing and multiplied it by a -1 all the way through, that would flip all these signs, right? Well, that's not true either. That means it's not odd. Again, sort of conceptually, that's saying like, is a y-axis reflection the same as an x-axis reflection? Right? Well, no, because they're not the same. Well, that only leaves one option, right? It must be that this is neither even nor odd. So again, same, opposite, or neither. Okay, so there's that. Go home, like look over that stuff again. Make sure you figure out kind of where you went wrong or what you have issues with. If there are things you have questions about, let me know. I would be happy to help you clear things up before it becomes a bigger problem, right? Reminder. Test 1 in just under 2 weeks. 2 weeks from yesterday, 19th. And that's going to be basically everything we cover up to that point. Most of that's in chapter 2, but a couple other things as well. And homework to do tonight. And there are lots and lots of tutoring things available to you should you need them or want them. Okay, everybody good? Anybody have any questions about anything? Okay. All right, well, go ahead and, if you haven't already, move stuff around, get into groups. So now that we know a little bit about what functions are and how they work, we know how to move them around and manipulate them in some ways. This week, we're going to be looking at ways that we combine it. Okay, so a couple of things for the next couple of days. We're going to look at combining functions using arithmetic. Combining functions using arithmetic, and then kind of defining a new operation that we call composition. We'll probably get to that kind of right at the end of today, but this is going to test a little bit our understanding of how function notation works, right? So again, just as kind of a reminder, when we talk about a function f of x, and maybe say that it equals y, this part is just the name of the thing, right? Just so that I don't have to keep writing, the whole formula out or whatever. There are times when it's nice to be able to just refer to a thing as f or g or whatever. So that's the name. The parentheses show us that we're writing this function called f using the symbol, well, whatever's inside there, right? And again, like x is our default, right? But this is the thing that we're using as our input or our argument. Input, argument, symbol if you want. It's the thing that's the placeholder, right? And the parentheses, again, just say like, okay, here's a function. The way I'm going to define it is using the symbol x. And then saying that it's equal to y, well, that's, equal to, same as, right? And then this is our output or our function value. So it's what we end up with, right? That's what it gives back. And thinking again about the like ordered pair thing, saying that a function passes through the point 3, 1 means that the x value 3 pairs with the y value 1 for that function. And in order to be a function, that's the only way that 3 pairs up with something. Okay, so with that kind of reminder in mind, we've got these 4 function operations where we maybe have a function f and we have a function g, and what we're defining are f plus g, and f minus g, and f times g, and f divided by g. So just thinking about this, notationally, if I've got a function f and another function g written in terms of x, what do you think? What does defining a new function called f plus g sound like it's going to do? See? Combine them by adding, right? This isn't a place where we went like weird with the notation and did some, bonkers thing. It's exactly what it sounds like it's going to be. This is take f and take g and add them together. So defining these, they pretty much do what they look like they're going to do. Now we're making a new thing out of 2 things we already have, right? So I've got a function f, I've got a function g. I'm making a new thing that's called f plus g, right? Again, think of this just like a name, right? It's a third function, it's a different thing, but we're naming it f plus g. And the reason we're naming it f plus g is because what we're going to do is take f and take g and plus them, right? We're going to add them together, right? Okay, so it's exactly what it looks like. So take just a second then and write down what the definitions for those other 3 things ought to look like. F minus g, f times g, f divided by g. Okay, so what's f minus g? Yep. F of x minus g of x. Fg or f times g, right? This is, again, the thing where we write 2 things next to each other. What we mean is multiply them. F of x times g of x. And f over g, f over g, or divided by g, right? Okay, so this is taking the 4 arithmetic operations that you've known forever, right? And applying them in this new context. But again, it's just take 2 functions, combine them, but combine them in certain ways. There are places where we may need to, do these things for like a reason. Like if I had, there's probably an example in the, well, maybe not. Something like, adding is like taking a total, right? Or subtracting might be something like finding profit if you know revenue and cost, right? Your total income, how much you spend, well, you subtract and you get the profit. So there are reasons for like combining these things. What we're going to work on first, though, is just kind of the mechanics of it. So this first example, we've got 2 functions that I'm just giving to you, right, as sort of an example. F is this, G is that. What we want to do is combine those and then simplify. You're probably not going to have room right there to do it. And then find the domain of each function and evaluate a -2. But first, let's worry about just doing the combining part. So take those two functions, f of x is x squared plus 3, g of x is -x plus 2, and just combine them using those four arithmetic operations, right? Add, subtract, multiply, divide. Be a little bit careful as you're doing it to just kind of think through some stuff as you kind of set it up. But pretty much you can just replace the function with, you know, the name of it here and then do the operation. Again, just be a little bit careful. All right, so I'm going to just give you a few minutes to kind of work on that in your groups and discuss, and then we'll talk about things. All right, quick check, just make sure we're all on the same page. Y'all in the middle. Tell me about the first one, F plus G.
I got x plus 5.
Okay, what'd you do?
I did like x squared minus 1x. I already did mistake.
Okay. What?
It was squared, not like 2x.
Right, yeah, so you combine things that are different, right? So you combine two things that are not like terms. That's okay. You're not the only one. What we need to do, like big picture, is take F and take G and add them together, right? Okay, so if it helps you to, you know, think about like what's going on, this is what's happening. We should be taking our two functions. I don't know how many fingers is two. Taking our two functions and adding, right? Because this said add them, so I should be adding. Our functions are x squared plus 3 and -x plus 2. Okay, now we're adding, so really those parentheses aren't doing anything important, right? X squared plus 3 plus -x, so I can write that as -x, right? Plus 2. And then last thing I would need to do, and this is where Miles ran into a little bit of a problem, combine like terms, right? So combine the things that they go together. X squared, that's x times x, minus 1x. Those are not the same kind of thing. right? So we don't combine those. So I would just leave this as x squared minus x, and then 2 and 3 give you 5. Everybody okay with that? Okay, we're still working on the other 3, or you got it? Still working? Okay, let's take a couple more minutes to finish those up.
So I can think of Okay, yeah, no, that's, yeah, yeah, there's no good, like, stuff that you're- It's okay. Good so far, so far? Okay, yeah, that's all. Yeah, on D, you're pretty much gonna like set the thing up, and then there's not really any where to go from there that we need to worry about for right now. Division's harder. Is all right? Okay. So subtracting all of this. So direct out plus. So this would be minus 2. Right, so like subtract the whole thing. So, yeah. Oh, yeah. You guys okay? Yeah, so you like distribute that negative through like subtract it, so it'd be plus x. Yeah. All right, so what does B look like? F minus G, same basic idea. Take the two functions, right? So the setup's going to be basically this again, except instead of adding, we're going to subtract. Everybody okay with that part? Okay. Then we just have to do it, right? Now we've removed the like new concept notation thing, this part that's, you know, maybe a little bit scary. Now it's just, I'll take these two things and, you know, push them together, right? So subtracting a quantity, what do we do? Yeah, flip all the signs, right? So, or distribute this if you want to think about it that way. X squared plus 3 minus negative x becomes plus x. and then minus positive 2, so minus 2, right? And then look for like terms to combine. X squared, okay, it's the only x squared in there. There's an x, it's the only x term, and then 3 minus 2. So something like that. Yeah? You feel okay about that? Okay. All right. Let's see, multiplication. F, G, or again, that's F times G, right? So this would be F times G. And then again, just like we've done with the other couple, what that really means is take whatever F is and whatever G is and combine them by multiplying. So we need to multiply those two things. How do we do that? Yeah, you got to do a bunch of distribution, right? It's a binomial expansion. You got a thing with two terms in it times another thing with two terms in it. To multiply those, you got to make sure everything, you know, hits everything else. Or FOIL, if you want to think about it that way. Distribute this to both and this to both. Or FOIL, whatever your preferred, you know, thing for doing that is. So we get x squared times negative x. Negative x cubed. Right, x squared means two of them times another one, so 3, and it's negative. Then x squared times 2. Three times negative x, and then 3 times 2. Then again, if there's anything to combine, we combine it. We've got x cubed, x squared, x to the first, and then a constant term. Those are all different kinds of things. So there's nothing else to combine, right? So just leave it like that. Okay. All right. So this, and we saw it with the subtraction thing too. We do have to be careful to remember that, you know, if a function has more than one term to it, especially like these do, that when we combine these, we're combining them as quantities. So like I have to, you know, I had to distribute the negative in this one because I'm subtracting, you know, a thing that has multiple pieces. I got to make sure I subtract them both. Here, when we're multiplying, same idea. I'm multiplying things that have more than one piece to them. So we got to make sure that everybody, you know, sort of hits everybody else, right? Okay, and then D, the one that looks the scariest, but actually we aren't really gonna have to worry about too much. This just means F divided by G. So F divided by G. We don't know how to divide polynomials yet, so we're just gonna leave that like it is. And even if we did, it's questionable whether that would really teach us anything else. So we're just gonna leave that like it is. There's not really any kind of like nice simplification we can do there that's worth it. Okay. Any questions at this point? All right, so you've got all four of those things. Then the other thing I asked you to do is to find the domain of them. Look at a graph if you want, think about what's going on, and then evaluate at x equals -2 if possible. What's the domain of these things in the first place? The individual functions before we start combining them. These are things we know now, right? A week ago we didn't know this, but we know now. You can look at a graph, or I can look at this. What kind of function is this? X squared, right? So, so it's a parabola. What's 3 do? Moves it up. Okay, what's its domain? Everything, right? The whole real line. You took a thing that's defined everywhere, you moved it up a little bit. Well, that doesn't affect the domain, right? Okay, so that first one. Domain's the whole real line, so negative infinity to infinity. Again, you could graph it if you wanted to, get a look at it that way, but it's x squared, shift it up. Okay, that's not going to change the domain. What about G? Well, it's going to look like y equals x. Just that diagonal line, right, through the origin. It's going to be flipped upside down, right? The negative's happening on the outside. This one you can kind of treat either way because it's odd, but flips upside down and then moves up. So again, none of that stuff is going to affect its domain because it's defined everywhere in the first place. None of those things that we just walked through are going to change that, right? Okay, so yeah.
Isn't that F(x) not like a U shape?
Yes.
So how is it's
Domain, yeah. The range is just, sort of half, but the domain is everything. Yeah, good. Everybody else okay with that? Yeah. All right, so we have these two functions that are defined everywhere. I'm going to call them nice functions because there's nowhere that they like break or stop working or anything like that. There's no weird stuff happening. What happens if I take, or what do you think happens if I take two nice functions and add them together? I think all the way back to, I don't know, you've been doing addition since you were 5 or something. Everything you know about addition. Does anything weird ever happen? Does it ever like break or go wrong? Or you find two numbers and you just say, well, I can't add those, shucks. No, right? Addition's fine. Addition's friendly. The function that we came up with was, I don't even know, what did we get when we added these together? Minus x plus 5. Well, that's still a parabola, right? There's more stuff going on here. We don't have the tools yet to figure out, how to describe that in terms of the transformations and stuff. So don't worry about that part. But it's still a parabola. What do we know about parabolas? They're defined everywhere, right? Okay. So when we start with two nice functions like we did here, if we add them together, because addition's a nice operation, then we get a third thing that is also nice, right? It's still defined everywhere. The domain of this guy is also the whole real line. Okay. So with kind of that idea in mind, we started with two functions that are nice. We added them together. Addition is nice, and I can't think of any time that addition does a weird thing or breaks or goes wrong or whatever. And we've got a third thing that was also nice. Think about how you think or what you think should happen and look at a graph if you want for subtraction and for multiplication and for division. Like, does the same thing apply? Or is any of those going to work differently? Take a couple minutes to think about and discuss that. All right, so adding was fine. What do we think about subtracting? It's good, right? It's still sort of friendly, right? So you looked at the graph, I assume, or looking at the function itself, x squared plus x plus 1. This is going to be something related to x squared, right? Again, we don't have the tools yet to like break down what the transformations are because that middle term, but it's something related to x squared still. And we know that x squared is defined everywhere. This is as well. See where we took these two things and multiplied them. What we got back is a cubic. Now, again, there's a bunch of other terms. I can't say that this is x cubed, but shifted right and up 4 or whatever. I can't do that yet because there's too much other stuff going on. But it's still a cubic, and what we know about cubics is that they are also defined everywhere, right? That's this guy that I don't know how to make with my hands very well. What's different about part D? Okay, so when you looked at the graph, there are like two different sort of chunks, right? It's in like two different sections, and there's like a, I think you said there's something that looks like a break. Yeah, okay, there's that. What are we doing in part D? Dividing. Ooh. Well, addition, subtraction, multiplication, those are all nice. Division, though, can go sideways, right? How? Where do we run into a problem with division? If you try to divide by, not negatives, negatives are okay, but.
Get it on the left side, right, go X, as that fails the line test.
Ooh, let's take a look at the graph real quick. I guess I could take my pen out of my mouth. X squared plus 3 over negative x plus 2. Zoom this out a little bit. Okay, so it's in these sort of two weird like branches. Doesn't look anything like other stuff we've looked at up to this point. It's subtle. We'll talk about this in a lot more detail in 6 weeks or something, but it actually does still pass a vertical line test. This gets real close to this line going that way. That gets real close to it going this way, but they never actually overlap or cross. Again, it's real close, but they don't. But what's happening there? Thinking about division again, like forget about the function specifically. Just think about dividing. When does division go wrong? One thing that you can't divide by. 0. Why can't you divide by 0? How do we usually think about division? We go back to like when you did it in 4th grade or something, right? Equal sharing, right? You've got a pizza, you have 4 friends, you divide it into 4 slices and you should, or whatever. Well, dividing by 0 doesn't work because if you try to divide by 0, say I have 2 cookies, but no friends, all anyone gets is sadness then, right? Maybe like I'm allergic to the cookies or something. I don't know. But you can't divide by 0, right? That's why we get this problem because look at the thing at the bottom, negative x plus 2. Can that be 0? It can't be 0 because that breaks what's going on with the function, right? Where would it be 0? What x value would make it 0? 2, right? Negative 2 plus 2 equals 0. Look at our graph. The thing Logan was describing And Halasia said too, where this like break happens, where does it happen? 2. When X is 2, you get this weird thing where the graph goes one way and the other way and doesn't cross, right? Because it's not defined at 2, because at 2 you would be dividing by 0. Like I said, we'll talk about this in a whole lot more detail later, but for now, the domain is everything except for 2, which we can write like that. Think of that as everything except for x equals 2, because 2 is the place that I would get 0 in the denominator, but division by 0 is undefined. It makes things behave badly. That's what's going on there.
What is the one between them?
So the symbol between them is a union symbol. It's like a little U, but not the letter U. So it's like a U-shaped thing. There's a, when you see this come up in the homework online, there's the little like tool tray thing, has a button for it, for the union. It just means you read it like or and. So it's negative infinity to 2, open there because we don't include it, right? It's like 1.99 is okay, 2 itself is not. And 2 to infinity on the other side, well, this means pick up just past 2, right? Because again, it's open there. So we're taking the entire number line and just erasing one single point at 2, if that makes sense. That's how you interpret this kind of like union of intervals like that, where they butt up right next to each other. You're just taking out one point because that one point gives you a problem. This thing is okay if x is 1.999. That's fine because it's not 0 on the bottom. 2 is a problem though. Okay. Yeah, and like I said, this is just kind of a precursor. We'll do this in a lot more detail later on, talk about like what it means, what it tells us, and that kind of thing. For now, it's just we're trying to avoid dividing by 0, basically. Okay, so what about doing this from a graph? F plus g of 0, f minus g of -1, f times g of 1, f over g of 2. What are these? X values. Okay, so I'm asking you to take an X value, look up things from the graph, and then combine them. Again, everything that you need to know should be right here on the graph. We could maybe reverse engineer what these functions are, like what the equations look like, and then plug in and then combine and everything. All that would get you is the same answer though, and be a whole lot more work and a whole lot more places to make mistakes. So if I want to find f plus g at the x value 0, what do I need to do? Okay. Plug in 0 for x, but you're plugging in on a graph, right? So that means find that x value and then see what the y values are to go with it. And then you would, in the case of like A, you would add them together. All right, so take 5 minutes or something to work through those. And keeping in mind that these are x values. Okay, so the idea again is gonna be that f plus g of 0 should be the same thing as f of 0 plus g of 0, right? And another way, by the way, you can think about that is that the thing on the left, if I'm, actually talking about what happens at a specific x value, the thing on the left, I can either do what we just did a minute ago and like combine the functions, like actually add them together in like the equation sense, and then plug in, or since they're the same, I could plug into the individual things and then add the answers together, and we get the same thing, right? That's what we need to equal. From a graph though, what I'm gonna do is sort of the right-hand side of that equation. I'm gonna look up these two function values separately and then add them together. So what's f of 0? Zero. Because when x is 0, the function f, that bolder line passes through the point 0, 0. That means its y value or its function value is also 0. So 0. And g of 0? 2. When x is 0, g is 2. Right? The y value that it goes with is a 2. So 0 plus 2 would be 2. Are you happy with that? Okay. All right. Tell me about B then. We're looking at the x value -1. So we're looking right there. And I want f minus g. What's f? -2. And g is 1. So this would be -2 minus 1. Okay. C, we're going to look at the x value 1. So right there. What is f when x is 1? Two. And what's g when x is 1? One. So 2 times 1, 2. All right, and then last one, f over g when x is 2. Here's x equals 2. F divided by g, well, what's f? 4, and g is -2, and 4 divided by -2 is -2. Everybody okay with that? So again, it's sort of, reinforcing, if not, checking again, our understanding, like being able to look up values from a graph like that, and then just combining them in the right way. I would suggest that for, things like as you're doing homework and for, hypothetical test questions that look like this or whatever, I would write this middle step where you're actually writing down like, okay, that's -2 minus 1. And that's -3, because all you do is write down an answer and it's not right. I mean, these are going to be worth like a couple points a piece or something anyway, but if you just write down like 5, and I don't know where that came from, like there's not a lot I can do, whereas, just doing some arithmetic thing is not that big a deal. All right, so for Thursday, think about this third example. This is a thing that you know how to do or probably know how to do already. You've probably, seen before or done in your real life. So think through that. And we'll pick up there on Thursday. All right, y'all have a good day. I will see you Thursday.